this is Jay. I'm a developer relation engineer at Aptos Labs. Today, let's take a look at custom indexer on Aptos. So this video will have three parts. The first part is I'll explain what is indexer and why do we need it. And the second part is how does the indexer would work at a very high level. And the third part is we're gonna dive into the code. Now we have two implementation of a custom indexer. One is in TypeScript and the other is in Rust. We will walk through the TypeScript one and also briefly cover the Rust one and talk about the difference and which one we recommend people to use. So let's start from the very basic. What is indexing and why do we need it? So I think for high performance chain like Solana and Aptos, usually it's pretty hard to read data directly from the chain because the chain is usually only optimized for reaching consensus on the data. It is not optimized for reading the data. So let's say you have your own contract, you have your own data structure. When you want to read the data, it will be much easier if you can store those data in a Web2 database like Postgres or MySQL. Then your frontend or any off-chain client can just connect to the Web2 database and read the data. Now everything will be very familiar and the whole process will just be like a Web2 service. So we can, here I'm looking at this full stack template I built. So this one is really simple. The contract part is like anyone can create a message and store the message on chain. And here, like if we don't have an indexer, if we don't have an off-chain indexer, then we basically have to maintain like a giant list or like a array type of data structure on chain that store all the messages, because each message is stored in its own object. Object is basically the contract account on Aptos. So if we want to say get all the message created by an address, it's going to be very difficult or like inefficient without any off-chain indexer. So that's where the off-chain indexer comes from and how it solves this issue. So once if we have the off-chain indexer, then whenever the user creates a message, the contract will emit a create message event. Then the indexer will parse the event and store it in Postgres database. So that's a high-level overview of what an indexer is and why we need one. And then let's talk about how we usually build the indexer. So if we just think about this problem without knowing any context. So the issue is like we want to parse the transaction and find the events related to our contract and store them, right? So the most naive approach is like we just loop through all the transactions from the block where the contract is first deployed until the most recent block. And we loop through all the blocks and loop through all the transactions, loop through all the events and find the one that's related to us and parse them. But actually, I don't think anyone would build it this way because it's it requires a lot of like boilerplate code. Instead, most of the chain provides like some kind of a streaming tool for you to read the events. So for some other chains, they support WebSocket. For Aptos, we support gRPC stream. So you can think of gRPC stream as an alternative to WebSocket, but it's using protobuffer, so it has a type definition and also has better performance. So by connecting to the gRPC stream, the indexer just need to specify which block height we want to start in indexing from, and it will automatically get all the transactions from that specified block height until the most recent one. And after the indexer catch up to the latest block height, it will just tag along with new block that's coming. So that's a high level how the indexer would work. Now let's jump into the code. So before we jump into the code, I also want to briefly mention the difference or like the relation between the Rust indexer and the TypeScript indexer. So functionality wise, they do the exact same thing, but we usually recommend people to use the TypeScript indexer for rapid prototyping. For example, if you are building for a hackathon or just hacking around, then it's much easier to use a TypeScript indexer because you also just use SQLite, which is like a local database, and it's just a couple files, and you just go ahead and define the table and define the transformation logic. Then that's it. It's very easy. But for the Rust indexer, it's more performant because it's in Rust, and also it has a just more how should I put it? It's just more performant and more complicated. Because Rust is strongly typed, you need to define, for example, define what does the on-chain struct look like, define what the database struct look like, and how to do the mapping. And just the boilerplate code is much more. So now let's look at what the TypeScript indexer. So now I'm at the VS Code and open the TS indexer directory. So we start from the package.json. You can see the dependency is pretty minimal. It's just Aptos proto and gRPC. And we only have this one command, which is to start the indexer. Oh, by the way, so if you want to learn more about the contract and the front-end part, basically it's the rest of the thing in this template. We have other video for that. You just go to my YouTube channel and look for the Aptos development 101. So here, let's go to the star.ts file. Actually, before we do that, let's also take a look at the environment variable. So here you can see we have the API key that you're gonna need it to connect to the gRPC stream. You can get it from the developers.aptoslabs.com. And you also specify the gRPC URL. So if it's testnet, then it's gonna look like this. If it's midnight, it looks like midnight.aptoslabs.com. Then the starting version, like at which transaction your contract is deployed, and in the end the contract address. So now let's go to the star part. So for the star part, we start from this run function. You basically call this, you like first set up the database connection, which is a SQLite database, and then just stream and then persist the transaction from the gRPC stream, and we do some log. Now let's go to the stream and persist function. So here we first create two tables because our contract is basically a message board where anyone can create a message. So we have one table that tracks the indexer status. So sometimes we use the term indexer and the processor interchangeable, but they basically mean the same thing. And once we have the processor status, you should track what's the last successful version this indexer has processed. So next time when we run it, you doesn't need to start from the very beginning. Like it doesn't need to start from the version specified in the environment variable. You can just start from the last successful version in the database. And then we create another table that store all the message. You can see we use the message object as the address because every message is in its own object, in its own contract account. Then we have the creator address, the timestamp stuff, and the message content. This allows us to just filter the message by the creator address or just filter the message by the message object address. And we can also do the sorting based on the timestamp. So once we have two tables ready, we try to read the last success version from the database. then we use that to get the starting version. Then we pass the starting version to the gRPC stream. Then the rest of the code is basically the transformation part. So we have this extract and save events function. Let's go to that. So inside of it, we can see we loop through all the events given a transaction, and we check the event type. So event type here on Aptos follows this format. So the first part is gonna be the contract address. Then the second part is like the contract name or like the module name, and the third part is like the event name. So in our case, it's gonna be contract address message board, since this is the name of our Mu contract, which is right here. You can see this is the module name or the contract name. And the last part is like the event name. So we have two events, the create message event and the update message event, which maps to the event defined in contract here. So if the event does match one of these two, then we know those are the events that's related to our contract. So we're gonna convert the, like, parse the JSON string to the event type, and this looks exactly the same as the on-chain version. And once we parse it, we can write it to the message table. So it's pretty standard. If it doesn't exist, then it means it's creation. So we just write it. If it already exists, then it means it's an update. So we're gonna overwrite the original content and the update timestamp. And after we're done with this part, we also will update the last success version. So next time when we restart the indexer, you know where to pick it up. So that's it about the TypeScript indexer. As you can see, it's pretty straightforward, and it doesn't take a lot of files. So if you have your own contract, it should be fairly easy to write your own indexer. So you just like define the event in the contract, and then define the table based on the events, and in the end define this transformation logic from on-chain event to like database record. So now we have covered the TypeScript indexer. Let's take a quick look at the Rust indexer, which is a lot more complex. So we start from this cargo toml file. So you can see we are using the Aptos indexer SDK, and let's look at the config for the Rust indexer. It's pretty similar to the TypeScript indexer. You also specify the gRPC URL, the starting version. This auth token is like the API key in the TypeScript indexer, which is name it differently. And then you have the contract address. Then you have the Postgres connection string, because for the Rust indexer, it's aimed for production. So we use cloud database like Neon, Postgres, or Google Cloud. And this whole thing is also like containerized using a Docker file. So you can run the Rust indexer on the GCP Cloud Run. So the typical flow is similar. So like the high level flow, as the first step, you define the table schema. Here we are using Diesel ORM as the database tool. So we define this table, and we're gonna run the database migration. Then all the table will be created. After we have all the table, we also need to define the struct of like the database representation and the on-chain representation, and how to do the mapping. And then we have the basically three steps. I think we have the processor step that set up the connection and all that stuff, and figure out what's the version it should run from. what's the transaction version it should run from. And then we have the extractor that will get the event and filter out the event from our own contract. And in the end, we have the store that will write those event and convert them to the database format. So a couple more things here in the Rust indexer is like we have two more tables. So one is this user stats table. So this serves as analytics dashboard to track how many message and how the user has created, how many message user has updated, and we also have the this package table and the module upgrade table that track the upgrade history of the contract. But those are just like nice to have things to demo more stuff. But the core business logic, like the message table, is are exactly the same across both indexers. So that's everything about Rust indexer. And if you have any question on how to build your own custom indexer on Aptos, feel free to chat with us on the GitHub discussion. So we have this discussion board here, and you can also reach out to us on Telegram or on Twitter, or just leave a comment under this YouTube video. So I'll see you guys next time. Bye bye.